to Jacket Academy Math Day 2. We're going to be back in your ACT prep workbook looking at where we left off yesterday. So yesterday we were able to get through the first 11 questions, and I hope that you had a chance to at least look over or try some of the next coming questions, just because it always is more meaningful when you've tried something yourself, even if you get stuck, for someone else to then explain it to you. It's going to have a little bit more meaning than if you're just watching someone else work it. If you look at number 12, it says the length of a rectangle with area 54 is 9 centimeters. So we know that the length is 9 centimeters, and we know that the area is 54. It says, what is the perimeter of the rectangle? If you think about a rectangle, we already know that its length is 9, but we don't know its width, and that's going to be something we'll need to know before we can find the perimeter, or the sum of all the sides. So I'm going to go back to what they told me at first, which is the area is 54. The area for a rectangle is length times width. So 54 is equal to 9 times the width. So I know that 9 times 6 is 54. That means W, my width, has to be 6. So if I go back to my picture, that means both of these widths are 6. And now they want to know the perimeter of that rectangle. The perimeter is going to be adding up all of those side lengths. So 9 and 9 and 6 and 6, which gives me a total of 30 centimeters, or K. Still looking kind of in a geometric way, looking at number 13, it asks me to find the measure of a specific angle. And so in this picture, it says that C is the intersection of AD and BE. If it can be determined, what is the measure of angle BAC? Well, first I have to know what angle they're referring to. Angle BAC tells me exactly how to draw that angle. From B to A to C means that I'm referring to this angle here. And I want to know its measure. If I look at the picture as a whole, though, there are actually 2 triangles within my picture, and those triangles meet at point C. Where these 2 line sections cross, it creates what are called 2 vertical angles, and those vertical angles are equal to each other, which means this angle is also 45 degrees. Another fact about triangles is that the angles within a triangle all have to add up to 180. So if I want to know the measure of this angle at the bottom, angle A or angle BAC, then what I'm going to do is start with the total of 180 and take off the ones that I don't need. Take off the 45 degrees and the 35 degrees, and whatever's left over will have to be angle A. So 180 minus 45 minus 35 leaves me with 100 degrees. So angle A or angle BAC has to be 100 degrees. We're going to continue looking at angles on the next one. We're looking at a pie chart or a circle graph of different choices. It says Antoine drew the circle graph below describing his time spent at school in one day. His teacher said that the numbers of hours listed were correct, but that the central angle measures for the sectors were not correct. What should be the central angle measure for the core subjects sector? So it's looking at how much time he spends in each of these parts of his day at school. And so what their teacher said is that the number of hours are correct, meaning 4 hours are spent in core subjects, 3 hours in electives, 1 at lunch and passing time, and 1 in choir. And so if we look at each of them, that means that this person has a total of 9 hours spent at school. So 4, 7, 8, 9 hours total. So what we're saying is the number of hours are correct. So this Antoine does spend 4 hours in core subjects, but 4 hours out of 9 hours is about 0.44. It's actually repeating. And so what we want to know is that's really not half. In the picture, it looks like the core subjects is half of the circle, and this isn't quite half. So we want to know how many degrees it should actually be. Well, in a circle, the total is 360 degrees. So what I want to find is 0.44 or 0.44 repeating times 360. So I'm going to show you 2 different ways to work the same question. One of them is going to be using the same kind of percentage method that we found earlier when we were talking about Jorge's hourly wage, is where I'm going to multiply the total 360 by this percentage or decimal, 0.44. And now that's going to give me an estimate because I did round that number, but 360 times 0.44 is 158.4. If I'm looking at these options, that's closest to 160. And I say closest to because I did round here. The other way is going to be to set up a proportion like we did earlier with the question about the map. We could say that 4 out of 9, and those are in hours, is equal to how many degrees out of 360 degrees. So when I set up this proportion, I'm just saying 4 out of 9 is the same as how many degrees out of 360. So I'm going to cross multiply here. 4 times 360, which gives me 1,440, is equal to 9 times x, or 9x. And then to solve, I'm going to divide both sides by 9, which gives me x equals 160. So I ended up with a much more accurate answer by using this proportion, but I was able to get close by using the decimal, and that decimal came from 4 out of 9, or 4 divided by 9. So 160 degrees is what that core subject section should be. Looking at number 15 takes us on to the next page. It says, this month, Cami sold 70 figurines in 2 sizes. The large figurines sold for $12 each. So I'm going to write this down. The large figurines were $12 each, and the small figurines were $8 each. The amount of money he received from the sales of the large figurines was equal to the amount of money he received from the sales of the small figurines. How many large figurines did Cami sell this month? So what we know is that if we were to add up the number of large figurines sold and the number of small figurines sold, that would have to equal 70 because he sold a total of 70 figurines. But if I add up the money, then the money should be equal, which means that $12 times the number of larges that he sold plus $8 times the number of smalls that he sold should be equal to each other. And so what I'm looking at is a system of equations. And so in this example, I'm going to want to solve this system of equations to find out how many large figurines he sold this month. What I'm going to look at is a couple of different ways that you could think about solving a system of equations like this. One of them would be to use that first equation to help us replace small, or the number of small figurines, with something else, with some other equation. So if you look at this example, what I can do is I can solve the equation for s. And what I would do is I would subtract L from both sides in order to move that L to the other side. So this is going to give me a new equation. S equals 70 minus L. And all I've done is kind of rearrange this equation so that S is solved for. The reason I'm going to do this is because now in my other equation, I want to take out the S altogether, take out the number of smalls, and replace it with that other equation, 70 minus L. That way I end up with an equation that only has L in it because I want to know how many large figurines he sold. So I took that bottom equation, 12 times the number of larges equals 8 times, and instead of using S for the number of smalls, I use the other equation, 70 minus L. Now I can solve this equation. Probably the first thing that comes to mind is when you see those parentheses is to use that distributive property. So that's what I'm going to start with. 12L equals, when I distribute that out, 8 times 70 equals 560. 8 times negative L gives me negative 8L. So that was distributing the 8 out to both pieces. Now I still want to solve for L. So what I'm going to do is move that negative 8L over to the other side by adding 8L. That gives me 20L. And the purpose of doing that was to get rid of the negative 8 with a positive 8. I still want to know what L is. So to get rid of multiplying by 20, I'm going to divide by 20. 560 divided by 20 gives me 28, or L equals 28. That means he sold 28 of the large figurines. I want to back up for a second, and I want to view this same problem from a little bit different perspective. And the reason I want to do that is because if you notice, what we did here was a lot of algebra. You had to have a plan in mind before you started the problem to know what it was that you were trying to accomplish, and then you had to be really particular about where all of your information went. And so sometimes that's not always our first thought. So let's look at number 15 again, only let's look at it from a different perspective. If you look at the answer choices, each of these represent the number of large figurines, and these are possibilities for the number of larges that he sold. But what we know is that he had to have sold 70 figurines total, which means if this is the correct number of larges, then I should be able to come up with my own number of smalls, which means if he sold 20 larges, that means he had to have sold 50 smalls because the two together have to equal 70. The same thing is true if you go all the way to the bottom. If he sold 50 larges, then he had to have sold 20 smalls to go with it. And I can figure out along the way. 70 minus 28 larges would leave me with 42 smalls. 70 minus 35 would give me 35 smalls, so 35 of each. And then 70 minus 42 would leave me with 28 smalls. And so that gives me two different answers, one large and one small, to then use for the prices. What I know is that the larges were $12 each. So if I do 12 times 20, that equals $240. And I know that the smalls are $8 each. So 50 times $8 is $400. We said those should be equal. Well, those two numbers are not equal, so I can mark off A as a possible solution. Now, this is a little more time consuming because it's more like guess and check. However, it's still a way to be able to answer the question even if I wasn't really sure how to solve or set up that system of equations. So if you keep checking, 28 for the large would be 28 times $12 for each large is $336. And then if you do 42 smalls times $8, that is also $336. And so when they're equal, like they told us they were, that's going to be my correct answer. So I can come up with that answer in a little bit different way, but by using the same idea. Looking at number 16, it says a car accelerated from 88 feet per second to 220 feet per second in exactly 3 seconds. Assuming the acceleration was constant, what was the car's acceleration in feet per second from 88 feet per second to 220 feet per second? That's a lot of feet per seconds. But what we're saying is that it accelerated from 88 to 220. So I can figure out how much faster it's going now than it was by doing 220 minus 88, so that I can figure out how much it went up. So that increased 132 feet per second. But I want to know how fast that was per second because that occurred over the course of 3 seconds. So if I divide that by 3, that will tell me how much I accelerated per second. So 132 divided by the 3 seconds it took for that acceleration to happen, which is 44 feet per second, and that is per second. That's how much I've increased the acceleration. So 44, feet per second per second. Number 17 says, in a plane, the distinct lines AB and CD intersect at point A, where A is between C and D. So let's try to draw a picture so that we have something to base our information off of. But it says the lines AB, remember that on my line I have these 2 points, AB, and CD intersect at point A. So I have another line here that crosses that line at point A, and it says that A is in between C and D. So here's going to be C and here's going to be D. The measure of angle BAC, let me switch colors so I can see. The measure of angle BAC, which is this angle here, is 47 degrees. Obviously that doesn't look like 47 degrees, but that's because I drew the picture myself, so it's not necessarily to scale. The question is, what is the measure of angle BAD? Angle BAD is what's called the supplement or the linear pair to the 47 degree angle. Angle BAD is this other section of that angle. They're supplementary because they form a straight line. Straight line is 180 degrees. So supplementary means that they have to add up to 180 degrees. So if I want to know what that angle is, I can do 47 plus that angle has to equal 180. So to solve, I'm going to subtract 47 from both sides, which leaves me with 133 degrees, which is choice D. Remember that in these, the huge majority of the information comes from being able to understand what they're asking or to use the terminology. In this case, I had to use that terminology to create my own picture in order to be able to answer the question. So make sure that you know or are familiar with those geometric terms as well. Number 18 asks us, in which of the following are 1/2, 5/6, and 5/8 arranged in ascending order? So ascending versus descending. Ascending means that they're going from smallest to largest. Descending means that they're going from biggest to smallest. So in this case, it's going to help if we have some frame of reference to be able to compare these. And you can do that a lot of ways. You can do that by creating them or giving them all a common denominator so that you can order them. Or you can figure out what they are as decimals, because a lot of times we can order and arrange decimals easier. 1/2 we know is 0.5. The other two we're probably going to have to figure out using the calculator. 5 divided by 6 is 0.83 repeating, and 5 divided by 8 is 0.625. So in that way, I can tell that it should go 1/2 is the smallest, then 5/8, that was this one, and then 5/6. So from there, I want them in ascending order. Notice that all of these have the same greater than or less than symbols in the same places. So I really just need my information in this order, and that is that very top one, 1/2. This says 1/2 is less than 5/8. 5/8 is less than 5/6, and that's the order we have them in. Let's look at one more together today, and then I'll leave you with some to look at in preparation for tomorrow. Number 19 says, in scientific notation, what is 670 million plus 700 million? So what we know is that in scientific notation, those are your answer choices. They are written in scientific notation. What we're doing is taking a number in between 1 and 10 as a decimal, and then we are adding a bunch of zeros to the end or to the front of it. That's the purpose of scientific notation. So this first number could be written in scientific notation by putting your decimal there, because we want it to be a number between 0 and 10. So we're going to use 6.7. And then that would be times 10 to the however many places we had to move that decimal. That's how many zeros we added. So what we're going to do is move it 1, 2, 3, 4, 5, 6, 7, 8. So that would be times 10 to the 8th. That's how many decimal places it had to move to the right. The same thing is true over here. I can put the decimal there, which would make it 7.0 times 10 to the, and then once again I'm moving it 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8th. I want to add those numbers together. So what I'm going to do is add together their parts, 6.7 and 7.0. What that gives me is 13.7, and if you look at my options up here, I don't see 13.7. The reason for that is because remember I said it has to be a number between 1 and 10. So 13.7 is definitely bigger. But I'm going to keep moving and then we'll come back to that. I have 10 to the 8th and 10 to the 8th, so I'm still using 10 to the 8th. Or sorry, that should be times 10 to the 8th. Then as I look at them, obviously we said we don't see 13.7 up there. So what we need to do is we need to move that decimal place 1 point further to the left to make it 1.37 so that it's a number between 1 and 10. Which means that to get all of those zeros back out there, we would actually have to move it 9 places to the right instead of 8. And so we would have 1.37 times 10 to the 9th power, which is D. Notice that A has 10 to the negative 9th. To the negative 9th would be moving your decimal place 9 places to the left instead, which would make it a really, really small number, 0.00000, etc. And so ours are big numbers. Those are going to be times 10 to a positive number. So what I want you to do for now is I want you to try at least numbers 20 through 25 on your own. Get as far as you possibly can. So if you're, let's say, a freshman and you haven't seen all of this stuff, try them anyway, because sometimes you can do a lot with the stuff that you have already learned. Get as far as you possibly can. Try to get through at least number 25. And then tomorrow we'll come back and look at these together. Have an awesome day, Yellow Jackets.